let's get started since we're at time. So reintroducing the operational data store, because I introduced the operational data store last Global Summit, and I want to do a better job of it this time because I want to get you excited about it. So first of all, for those of you who don't know me, I'm Matt Spielman. I'm the manager of product management for FHIR. My team of product managers is responsible for a lot of the data services within FHIR. So the unified care record, the shipping of data over to Health Insights, some of the operational stuff like security, auditing, usage reporting, patient matching, provider matching, as well as our patient engagement platform, which is Personal Community. So I've been in InterSystems since January of 2011, so I'm starting to roll up on 9 years now, which is kind of crazy. That picture was taken, I think, in like 2012, so you can see how much more gray hair I have now. But and I've been doing one thing or another in healthcare for about 20 years. So I started out, literally crawling through crawl spaces, pulling network cables, and I've just kind of stuck with it, and here I am now. So quick show of hands here for those of you who are our current unified care record, aka information exchange customers. How many of you have ever said this patient is taking too long to load? Yeah. Or, why is this global on my edge gateway that holds audit data so huge? I know some of you, particularly those of you who have been around for a while, are doing that. Anyone here using FHIR yet? Playing around with FHIR? Well, I know. Good, because the F in FHIR, that's supposed to mean fast, right? But if you've played around with FHIR in 1503 of FHIR, I'm not sure if fast is the word I'd always use. So what are we going to talk about in this session? I'm going to tell you all about the ODS. What is it? Why did we build it? How does it work? And what do you get out of it by having it? Talk a little bit about the nuts and bolts of the ODS, because really where people start to get a lot of hand-wringing about the ODS is figuring out how this fits into your current infrastructure plan in terms of capital, resources, that sort of thing. So I'm going to give you some information to help you understand what are the things you can do that impact how you plan for it. And then I'm going to talk about how the ODS fits into the larger long-term strategy for the FHIR platform. So let's get started. So the operational data store, ODS. We introduced this in 2018 one of FHIR. So 2019 one of FHIR, which we released earlier in the year, was the second release of FHIR that has this functionality in there. And if you remember nothing else about the ODS from this presentation, there are 2 points I want you to remember. One is the ODS is nothing scary. The ODS is just a centralized cache of the clinical data that exists on your edge gateways. The other thing is the ODS is where the FHIR gateway lives now. So in 1503 of FHIR, we had version 1 of the FHIR gateway, which was its own freestanding instance. It would talk to an access gateway, get the data. I'll have some nice diagrams that show you how all that works in just a second. The FHIR gateway, for very practical reasons, now lives directly on the ODS. So why did we build it? Well, we're really looking at 5 particular challenges and opportunities with our customers and within healthcare that we needed a way to deal with better. The first of which was dealing with the size of patients. So if you think back, for those, we've got HealthX here as one of our oldest customers, and you think about how big a patient record was 7, 8, 9 years ago, when mostly we were just getting HL7V2 data, maybe a couple of CDAs trickling in, to now we're sucking in data not just from HL7V2 and CDA, but also unstructured data, data from custom data sources, data from payer files, and the size of our patient records is just getting huge, not just in terms of data footprint, but also in terms of the number of streamlets in there. So you're going from having a patient with maybe 20 or 30 lab streamlets in it to some of our customer sites. We're seeing hundreds, in some cases thousands, because maybe it's a very sick patient. They've been in the lab, they've been admitted to the hospital several times for long periods of time. That's a lot of blood draws. That's a lot of bedside telemetry. And what that means is, no matter how big the hardware you throw at your edge gateways, the time to retrieve data from the edge gateways has been ticking up just purely as a function of size. The other thing is, FHIR is the train that no one can avoid, right? I tried to sort of dismiss FHIR maybe 6, 7 years ago when this big Australian guy came to me and said, I'm developing this new standard and I want InterSystems to work with me. And I said, oh, that doesn't sound really very interesting because all of our customers are really happy with documents. And then, 3 years later, we had a whole bunch of customers suddenly saying, where the heck is your FHIR support? And now it's very important to us that we are staying at the forefront of being able to support FHIR for our customers. And what are some of the things that our customers really need? Well, obviously, FHIR needs to be fast. It needs to be really fast in terms of how it responds to the initial request for data, because most of the time with FHIR, at least in the way that we're talking about it right now, it's an end user sitting with an application on their mobile device, on their computer, whatever it is, and any time that it takes to get the data to them is time that they're waiting, staring at a spinner on a screen or some other kind of thing that's really undesirable behavior for that end user. The other important thing is with mobile devices, they're not always online. Sometimes you want to take stuff offline. And one of the key things about FHIR is there's this concept of a stable resource identifier. The number that refers to a particular medication on a FHIR server, when I go back there an hour later, 2 hours later, 4 days later, that number should still resolve to the same medication. And we weren't able to do that with the first generation of the FHIR gateway. And then the other thing is making sure that there's no special preconditions to being able to get that data. So there's no funky workflow that an application developer has to do in order to ensure that the data is available in the FHIR gateway. It just has to be there as though it were any other implementation of FHIR on the planet. So some of the other things, scalability. We want to be able to take advantage of vertical scalability, which just means your server's not performing enough, throw a bigger server at it and be able to get performance, make sure that the performance gains that you get from having that better hardware equates into fairly linear performance increases. Additionally, we want to be able to lay the groundwork to support horizontal scalability as well. For those of you who have been to a lot of the SDC sessions with the data platforms group and some of the cloud technologies they're talking about, things like sharding and elastic scalability, we want to be able to leverage those things to deal with both the storage and the response times of the unified care record, and doing the ODS helps us do that. Additionally, we don't want to just drive down the amount of time it takes to get a record. We want to drive down that variance as well, right? Because sometimes a fetch might take a second, half a second, quarter of a second. Sometimes it might take 5. And that is purely a function of load on edge gateways and other things factoring into a slower response time. The other really big one is that auditing thing that I was talking about, which is we want to audit every single request for patient data that comes into the system. That doesn't necessarily mean we want to store a whole other copy of that data every single time. So what the ODS gives us is, first and foremost, auditing doesn't happen on the edge gateways anymore when you have the ODS. Auditing happens on the ODS. And we're only auditing data that gets sent over the wire to the system that requested the data. Because remember, we're taking data from 5, 10, 15, 20 different data sources. Some of that information is going to get deduplicated. So not all of it's going over the wire. So if you audit what comes off the edge gateway, that's not necessarily the best representation of the data that the requesting system actually received. And we also want to make it a lot easier to purge data out of the system. Because do you really need an audit record from 5 years ago? Depending on your regulatory environment, you might not. So how do we make sure that we are not just filling up the disk ad infinitum with audit records? And then for those of you who just came out of the HealthShare New and Next, the user group sessions, a lot of the things that we want to do that are very forward-looking with the unified care record and with Health Insight and even with some of the enhanced decision support stuff and other things that we're working on really relies on having something that like the ODS in a HealthShare deployment in order to make things function and scale appropriately. So how do we go about doing this thing? Well, before the ODS, so which is probably most of you who are running HealthShare Information Exchange, aka Unified Care Record right now, this is what it looked like when a system sends a request to the access gateway to get data. The access gateway says, okay, I'm going to go to the edge gateways, I'm going to fetch the data. The edge gateway, depending on how much data there, sits there and cranks for some period of time to identify all the streamlets that need to go. Then it calculates consent on each one of those streamlets before it sends it to the access gateway. Then it goes to the access gateway. The access gateway has to aggregate all those streamlets together from that edge gateway and all the other edge gateways, and then you get your response back. And obviously, if the patient is very small, that stuff happens pretty much instantaneously. If your patient is really big, that can take longer. And it can even take longer when you're dealing with multiple edge gateways. So let's say you're trying to generate an on-demand CDA document so that you can push it out as a notification to another system. Well, your request comes in, It federates that request out to all the edge gateways, and you're gated by the slowest edge gateway in terms of how quickly your access gateway is going to respond to that. So what's different with the ODS? Well, same thing as before. We've constantly got data flowing into our edge gateways. That's never going to change. There's always going to just be a fire hose of data going into our edge gateways. But now, instead of waiting for any requests to come from the access gateway, we're immediately pushing that data to the ODS. And the ODS is storing that data as the data flows in. It's doing all the aggregation, deduplication, terminology application things as it goes. So that when the request comes in from the access gateway, the response is instant and consistent because all the data, all the real heavy lifting has already been done. Now, what about FHIR? Well, this is what FHIR looked like in the 1503 release of FHIR, which was the only release that had the version 1 FHIR gateway. So imagine you've got your cool little Smart on FHIR mobile app, something like that running on your phone. Maybe it's a patient engagement app. And it sends a request into the FHIR gateway to get data. The FHIR gateway goes to the access gateway. The access gateway goes to the edge gateway. It crunches data. It sends that data back to the access gateway. The access gateway churns. It sends that back to the FHIR gateway. The FHIR gateway churns. And then finally, you have a resource that's available to return back to that mobile device that requested it. With the ODS in place, again, so everything here is what you just saw, right? The data is constantly flowing into the ODS. The ODS is constantly updating its cache. In addition to constantly updating its cache, it's also updating the cache data for FHIR endpoint, for the FHIR endpoints that you have turned on. And I'll talk about that in a second, so that the request is instantaneous. You're talking about a matter of milliseconds as opposed to potentially a second or more for the data to make that big, long, circuitous route through all of those different components. And more importantly, it's very consistent. On auditing, this is really, I think in some ways, one of the best parts of the ODS is what it lets us do with auditing. So previous to the ODS, let's say you had a patient record on your edge gateway, and that patient record basically constituted 10 megabytes of XML. A bunch of observations, other stuff. That's a fairly big record for a single edge gateway. So your edge gateway is storing that record, and your first request comes in. And the edge gateway saves a copy of that 10 megabytes off to the audit global. The next one comes in, 10 megabytes. The next one comes in, 10 megabytes. The next one comes in, another 10 megabytes. The next one comes in, and it's another 10 megabytes. That could have been 5 requests from 5 different users in the clinical viewer within a period of 1 hour. And for that 10 megabytes of data, you've logged 50 megabytes of audit data. And you've got 60 megabytes of total storage now taken up by that patient record in your system. With the ODS, we do something different. So again, still, we have our 10 megabytes of data on the edge gateway. That's what was constantly flowing in. And because it's constantly flowing in, it's going straight to the ODS right away as well. So you start out baseline, 20 megabytes of storage being stored there. Then what happens? Request comes in from the access gateway to the ODS. We log an audit record. We log another audit record. You get the idea. We go through all 5 iterations. What's different this time? Well, the difference is this time we're not auditing the whole record. We're auditing a pointer to the original data that was sent over. So that if we send exactly the same data every single time, this is just a small little manifest that says, here's all the records that we sent off. It's about 50K a piece, which means when it's all said and done, the total storage in the exact same use case is just a hair over 20 megabytes of storage. And the other thing is, it's a more accurate audit record of what actually went over the wire to the requesting system, because it's the data that came out of the ODS, which has already been aggregated, normalized, deduplicated. So so if you had a bunch of data that was stripped out because of consent, for example, you know that exactly what data was sent to that requesting system. Similarly, with performance, if you can imagine, obviously I tried to make it evident in those slides, the arrows are sort of coming back a little bit faster. Well, let's put some actual numbers on here, because we did do some real analysis on this to see, in an apples-to-apples comparison on an internal development environment with a fair amount of data loaded into it, what were the deltas on performance that we're seeing with the ODS in play versus without it? So the amount of time that it takes for the data to essentially get from the ODS to being stored in the database for the clinical viewer. And that's the best metric that we have, because at that point then, any customizations that a customer has in the clinical viewer, things like browser performance, computer to server connection speeds, all that starts to come into play and make it a little fuzzy. So the best metric that we have for comparison is how quickly can we get the data from the ODS stored into the database for the clinical viewer and ready to be viewed? And it's 4 times faster. On the FHIR side of things, how long does it take to get that first resource back? It's on an order of magnitude faster. So it's about 10 times faster with the ODS in place than with the previous version 1 FHIR gateway in 1503 of FHIR. And then after you get that done, the subsequent requests coming through are going to be faster as well, just because of a number of optimizations that we made in the FHIR stack that's present on the ODS. So nothing, trivial. I mean, those are significant performance improvements. So that's the good stuff. So then what's the stuff that you need to do in order to take advantage of it? And then this is where we get into the planning aspects of dealing with the ODS. So planning for the ODS is a balancing act. And it's between 2 things that you need to consider: performance and resources. You've got the faster you want your rabbit to run, the bigger your hog has to be. The bigger the server that's driving all this stuff. And the primary driver there is going to be storage, but there's some compute considerations there as well. I'm not going to get down into the weeds in this section on you need this many cores, you need this much RAM, you need solid state drives, you need this much storage. That's what Mark Belinsky is for. If you've never met Mark, you should talk to him because he has lots of, first of all, he understands the architecture of the servers way better than I do, and he also has lots of spreadsheets that he can use to help you size exactly what you need. But basically, this is the first sort of set of things that you need to think about. And when I say performance, what do I mean? Well, it's a cache. It's not a permanent store, right? So there are factors that are going to impact how long data resides in the ODS, and I'll talk about all those in the subsequent slides. If the record that you're requesting is currently cached in the ODS, you're going to get a cache hit, which means it's going to respond very quickly. If for whatever reason that record is not present in the ODS, you're going to get a cache miss. What does a cache miss mean? It means that the ODS is going to have to go to the edge gateways and fetch that data the way you would in previous versions without the ODS. So just to make it clear, the baseline of performance for all of this is essentially the same performance that you have in 1503 of FHIR without the ODS, although actually even a little bit better because there are some other transport enhancements that you get as part of the 18.1 release. So, but to keep it simple, let's say your baseline of performance is what you have right now if you get a cache miss. Obviously, if you want to avoid cache misses, and those are really impactful to your business or your end users, and you really want to make that a priority, then you're going to make this guy a lot heavier. You're going to store more stuff in it. You're going to cache data for longer to ensure that you have a better chance of getting a cache hit. So the next big decision point is, if you want to use FHIR, which version of FHIR do you want to use? In the current shipping version of the operational data store with the FHIR gateway, we support 2 flavors of FHIR, FHIR DS2.2, and then the subsequent version, which is FHIR STU3. You can do one or the other or both. That is not a free choice. And what I mean is there's a cost associated with it, which is that each FHIR endpoint that you turn on is going to add a multiple of about 2.5 times the original SDA record in storage. And that sounds like a lot. And the reason is you first have the act of transforming the SDA into FHIR. And we do that beforehand, and we store the resources, the FHIR resources on disk. And the reason why we do that is for performance, because for a very large patient, that transformation process can take a long time. The other thing is a function of the FHIR standard itself. If you look at the FHIR spec and you're feeling really masochistic and you want to read through the whole thing, it has a lot of requirements around search parameters for specific resources. And each one of those search parameters translates into an index. Indexing is expensive. And so in order to provide the best experience for application developers and end users who are using FHIR applications on top of the FHIR gateway, we really need to support all of those sort of base search parameters, which means we need to be able to support those indexes, which means we need to absorb the storage cost of storing those. The next thing, and this is the other really big driver, is data retention. How long do you want to store data in the ODS, and when do you want data to go into the ODS? And there's, in addition to the FHIR stuff, 4 dials that you have control over. So the first one is auto load. Most customers are going to want auto load turned on by default. unless you have a very specific reason to not. And what does auto load actually do? Well, auto load is going to say when the trigger event happens, load this patient into the ODS. Now, out of the box, there's basically two trigger events. One is when data arrives in the system, and one is when somebody goes to open that record. So if somebody goes to open that record, it'll load it into the ODS if it's not present. If you want to just have the ODS be reflective of the current activity in the system, then you basically turn on the auto load and it'll start basically when a patient arrives on an edge gateway, it'll get cached in the ODS. The next thing is how long do we want to keep that data? So the first thing is your retention policy. And your retention policy says, do I want to keep the data forever? Because that's one option. And for certain customers who have really high performance demands, they might want to just store all their data in the ODS. For those that don't, your retention policy has two main decision points. When do I want the timer to start for basically expiring that data in the cache? And there are two things that it can be. It can be based on solely end user access. So that patient gets cached, and let's say nobody accesses that record for 30 days, and your timer is 30 days, well, then it's expired at 30 days. If you want it to be activity in the system, it can also be that. So it can be a combination of end user access as well as ADTs and other activity coming into the system that will basically keep that record alive in the ODS. The next setting is when does that timer go off? And that's the retain days. So retain days is basically once a certain amount of time has gone by one of those qualifying events that keeps the record fresh, when do we mark this record as expired? And then once that you hit that point, then you hit the audit retain days. And how do those play in with each other? Well, let's say patient, you get an ADT for a patient, you load them into the ODS, your timer's 30 days. 30 days goes by, you don't get any more traffic on the patient and nobody opens it up. We flush that record from the ODS. You reclaim that storage and it's gone. Let's say, however, during that period of time, somebody actually went into the clinical viewer or you pushed out a document based on that record. Then your audit retain days timer starts after this timer goes off. And this is going to be something on an order of years, probably, in a lot of cases. Because this is really saying how long, because you remember, if you think back to that slide where I was talking about the pointers to the audit record, how long after an event happens do you want to be able to essentially rehydrate one of those pointer records into the full audit record? And that's what this controls. So if you still have no activity on the patient after this amount of time expires and then this amount of time expires, we flush that data out. So what does this end up looking like in terms of a curve? So if you were imagining this was a single patient in an ODS, when the data arrives into the ODS is going to be driven by that auto load function. So if you're doing it where only it's when somebody accesses the patient record, it's going to push that line over this way. If it's right when the data arrives, it's going to be over here. How long you retain that data is going to be a combination of those other three settings: your retention policy, your retention days, and your audit retention days. And then the size of the data here is going to be a combination of which of the FHIR endpoints have you decided to support. Now you can imagine if you start stacking up and sort of almost like a Monte Carlo simulation, right? You start taking all these curves and stacking them up, tens, thousands, hundreds, millions. It's going to start to approximate kind of a curve, right? So you're going to have an initial spool of time as all of your records start flowing into the ODS. And then at some point, it's going to start to reach relatively steady state. It'll never be completely flat because you're always going to be adding new patients into your population. You're always going to be pulling new data sources on. But depending on how aggressively you tune those settings, that's going to be what determines sort of where your kind of functional plateau is going to be. And it's important to remember that this is cumulative for your entire HealthShare deployment, right? Because even though you are still going to be spending money on disk storage for audit records, even after you flush even after they expire, remember that you're going to be saving storage on your edge gateways. So you're not going to have, as soon as you turn the ODS on, all audit global growth on your edge gateways stops right in its tracks. So if your audit global is 10 terabytes now, it's never going to get any bigger. And so you are increasing the storage footprint on the ODS as a sacrifice, to get that storage off your edge gateways and store less in total. So if you were to add up all the systems involved, let's say you were to take a customer like HealthX and feed all their data in from day one. One system is just HealthShare without the ODS, and one is HealthShare with the ODS. Then you take all of that activity and you add it in. Basically, the growth rate for the non-ODS deployment of HealthShare is going to be multiples higher in terms of that growth curve. And of course, if you're one of those people who decides, we don't really care about the cost of storage, we want super fast response times on all this, you could just have it retain everything forever, in which case you just have a linear growth curve of storage in the system. So, and actually, I did put a slide together for it. So this is sort of reflective of what I was talking about, right? Which is initially, because you're storing 2 copies of that data in the ODS, you're going to start out higher. You're very rapidly going to reach an inflection point where your overall storage costs are lower with the ODS than without the ODS. So, that's sort of the nuts and bolts of it and the things that you need to consider when doing it. Now, where are we going with the ODS? So I think a lot of you who were in the user group sessions got a good flavor of sort of what our designs are with the ODS, so what we think it's going to let us do in the future. But the first thing that's important for those of you who weren't there is that the ODS is going to be required in HealthShare 2020.2. So if you upgrade or you install a new copy of HealthShare 2020.2, your HealthShare production deployment is not going to start without the ODS present. You have to have it. You can turn it way down so that you've got one of those low curves in terms of storage cost. But we're doing that for really a couple of reasons, which is first of all, we need to, as a software development company, have kind of a common baseline of functionality across all of our customers in order to be able to create innovative solutions. You could come up with the best thing in the world, smart on FHIR application that we want to make available to our customers, and if they don't have the FHIR gateway present, or if they don't have any of the other things that depend on the ODS, like perhaps some of the enhanced decision support stuff, you're going to be blocked out of a lot of really good functionality, and we want you to be able to use and adopt that. But it also makes our lives simpler because it means that we instead only have to test less configurations with the software, and it makes it easier for us to get software out the door faster in a high quality way. The other thing is that the operational data store right now is basically a very large version of the way data is stored on the edge gateways. At some point, probably in the 2020.2 release, but it might drag out a little bit longer depending on how development goes, the operational data store is going to become a fully relational database, which means that instead of storing a whole bunch of streams of SDA, it's going to have a relational data model that is basically based upon FHIR. And so we're going to take the FHIR schema, we're going to use our technology to automatically generate a persistence data model for it that flattens things a bit so that, because there's a lot of fairly abstract constructs in the FHIR data model that don't really lend themselves well to being in a relational database. So we're going to take it, we're going to flatten it a bit so that it behaves well as a relational data model. And then that does a bunch of things for us. First of all, it gives us a data model that is much better understood than the SDA model. You have to kind of learn SDA. If you come from healthcare and you've worked with FHIR before, you'll understand the data model out of the box. The other thing is that it means that we no longer have to store a copy of the data for FHIR. So that 2.5x multiple, that goes away because now we can build those resources on the fly because the impedance, sort of the data model mismatch between where we're coming from and where we're going out over the wire with FHIR is much lower. So I mentioned that. And the other thing is, once it's a relational data model, we get another really cool thing that we can take advantage of. So we've spent a lot of the last year working hard to get HealthShare onto the InterSystems Iris data platform. And one of the really cool features that it has is sharding. And so sharding is a great horizontal scalability technology. And with the operational data store as a relational database, we can now take advantage of sharding. We can scale it out for storage and performance because, obviously there's sort of there's kind of an asymptotic curve with hardware, right? If you try to solve everything on one big piece of iron, the cost is not linear, right? Eventually you get to a point where you're switching to platforms that can support huge numbers of cores and huge amounts of storage. You max out your SAN, you have to get a new SAN to add more storage. So you get this very chunky, very steep growth curve with your hardware resources. With sharding, that's much less of a problem because you can take smaller servers and roll them out, scale them out as your system load increases, as your storage increases. And so that's something that we're very looking forward to. In the much longer term, the operational data store is going to become the authoritative store of data within the unified care record. And what that'll look like is it'll probably happen in a few phases. So the edge gateways will probably stay as they are, but the operational data store will essentially become the source of truth. So once we have these relational data model changes in, and we are confident in the scalability and the performance and the robustness of the data model, it won't be a matter of how much data you want to store in the ODS anymore. All your data is going to go to the ODS. And we'll probably let that soak for a major release or two. And then some point, probably a year and a half after that, we'll turn off the storage on the edge gateways. And the edge gateways will just become pass-throughs. They'll be stateless, which means they're not storing any data, and really they just exist to transform data from their source standard, the source protocol, into basically FHIR so that we can store it within the ODS. And so I hope that was a more digestible version of this than last year. Last year had a lot more graphs and it was a bit overwhelming. So I hope I got the point across this time in a way. And we'll find out right now because you get to ask me questions.
This is probably a quick answer. You mentioned that the ODS is now a relational data store.
It will be. It is not yet.
Okay. Does that infer that it needs to run within a relational database system? Meaning MySQL, Postgres, and the equivalent?
We have our own relational database. It's called Iris. So it's going to be on Iris.
Okay.
Yeah. Just like it's on Cache right now, and Cache supports relational access as well.
And that does that require within AWS running within a RDS instance, do you know? Or can that run on a...
So I'm going to plead a little bit of ignorance here on my cloud technology chops. I do know that we have customers who have already deployed in AWS, others who are considering it. And as far as I'm aware, there are no major technical barriers to usage of FHIR or really any of other products in AWS. Now, how that relates to sharding and other things, that's where you really want to start asking Mark Belinsky or some of the other systems people for questions about that.
So I have two questions. First one is, how does consent work with the ODS? Mm-hmm. And the second part is, when you store the data, is it already aggregated? It kind of plays with the consent. Is it already aggregated, or is it still broken down into the individual facilities at that point?
That's a great question, and I'm gonna get really down into the weeds here. But so when data arrives on your edge gateways currently, so if you look at the streamlet definition within FHIR, the streamlet definition in FHIR basically says for a medication there are 1, 2, 3, 4 rules that we're going to evaluate in sequence to figure out whether this record that came in matches with another record that came in. And it's usually things like filler ID, placer ID, medication code, and there's sort of a cascading set of rules that evaluate. And if one of those rules hit, then we say, oh, this record matches to this record. We're going to deduplicate these things, and we store a link key, which basically says these 3, 4, 5 streamlets are all the same medication. And we essentially do the same thing on the ODS, in that when the data comes in, we're generating these link keys, but we're not doing it destructively, right? So it's not like when data comes out of the access gateway, we've stripped out all the ones that are not sort of the best match for a particular record. So that means that we can very rapidly build that deduplicated record, but we store all the data there with basically all the math done already to help us do that rapidly, which means that when consent gets into play as well, it means that we can evaluate consent off of the streamlets before we pick the best match, so that the best match, if it's blocked by consent, you'll get sort of the next thing that matches with it, if there is anything that matches. So yes, it works with consent the same way that the access gateway currently works with consent. The big change is that instead of evaluating consent when the data leaves the edge gateway, we're evaluating consent at the ODS. The other cool thing about that is it means that the FHIR gateway also uses consent as well. in the same way that it did before, but just much faster because we're using that same plumbing, and we retain a link between the original SDA data and the FHIR resource that we transformed it into. So basically, when the consent evaluates against the streamlet, it also can evaluate against the FHIR resource. Interesting to note about that as well is that, let's say I have my big 10 megabyte patient that came in, and the only access to that record is ever through the FHIR gateway. And maybe all they ever do is access 1 or 2 megabytes of data for that record. When the retain timer goes off and we no longer need to hold on to that record, we will purge the stuff that wasn't accessed. So because it wasn't accessed, there's no reason to audit it. But the audit record that does point to those resources that were retrieved will pull that. The other thing is, if we only ever access the SDA, for example, we won't store the FHIR when we have to retain the data for auditing. So we try to drive down that storage footprint as aggressively as we can, while still ensuring that our customers are able to comply with any laws in auditing and that kind of thing.
You mentioned triggering the upload of the patient data based on updates or access.
Yeah, I forgot there's a really cool thing about that. Yeah, sorry, ask your question.
I was just wondering if do we have the ability to control that at a lower level, like a certain type of access?
That's the really cool thing that I forgot to mention. Yes, I'm glad you asked that. Thank you. Yes, so we, as a general ethos in HealthShare development, we are trying to do everything as an API, right? And so we built an API on the ODS that you can tell it to load a record. So for example, if there is a sort of non-traditional event happening in your system, or like a, other than an ADT or something coming in from a feed, where you know that that's something that you want to use to trigger the ODS to preload so that you don't have that spooling time to get the data from the edges, that's there. And it's a public API, it's a stable API, it's versioned, and so you can safely develop against it.
You just have it load all your data?
You can.
Without, I mean,
Yeah, you can. That's, I think, the Weird Al movie UHF or whatever it was, where people get to drink from the fire hose. That's about as fire hose as you can get, particularly for as large a data set as you have. But yeah, you can absolutely do that. So basically what you would do is when you deploy your ODS, there's a command that you can issue that just says load, and it'll just start grabbing everything and dumping it in. Any other questions? Yeah.
Is there going to be any, with the iris sharding and all that good stuff, is that going to be applied to the Atna log at all? And or is there any way that you're going to be making the Atna log like faster to search?
That's a good question. One of the optimizations that we did in 18.1 was to enable you to move the Atna log off of the registry, which was sort of the first major pain point there. So yeah, right now you can put it onto another system, and if your goal is just to reduce cost, put it up against some lower tier storage. Obviously, if you're asking about performance on accessing it, that's a different question. And we tend to be a little less protective of the Atna log, just because of the nature of what it is, So I mean, I think that probably you could shard the Atna log. There's enough data in there of use to be able to basically identify a shard key, which is basically, or auto sharding, which is basically just is the algorithm that determines how to spread that data out across multiple databases. We haven't done it yet. We haven't experimented with it yet. It's probably a configuration we should try testing out at some point. I would much rather get the audit log and kind of refactor it so that it's a bit more normalized and sort of streamlined in terms of the data that it stores. Well, yeah, I mean, because there's a lot of, we store a lot of unstructured, structured data in the audit log, a lot of XML and stuff that we just don't need to. And there are some opportunities there to optimize it. It just hasn't percolated to the top of the priority list yet.
So when data comes into, let's say, Edge A,
Mm-hmm.
and the patient also has data on Edge B, does Edge B's data also get loaded
Yes.
when the data comes in?
Yeah, so if, so let's say you've got, your Exchange works, right? Yeah. So let's say you're at Hixney and you guys have been running for ages and you've got a ton of data, and then you upgrade and you turn on the ODS and an ADT comes in for a patient. The ODS will essentially do a fetch of that patient record. So what it'll do is it'll get the record in so that it's current, and then it will start feeding automatically. So that's an important thing to mention, is that if a record is not in the ODS and your policies don't basically have the auto load stuff on, then the data won't go in until you have that data refreshed. Now, once you do, so like let's say, for example, you don't want to auto load any, but you have your own special hook that you've defined, which is what you want to use to trigger data to load in. Once that patient is loaded in, any new data that flows into the edge gateways will flow to the ODS. So you don't have to constantly tell it to load and load and load. So let's say you have, adding a patient to a research study is your trigger for having a patient be in the ODS. So you add the patient to the research study, you trigger the API on the ODS to load that patient. That patient's data will now automatically flow to the ODS regardless of any other settings, and will be retained in the ODS according to the retention interval settings and policies that you have configured.
Is there any impact on the clinical viewer at all because of ODS and different versions?
Yeah,
different versions?
Yeah, positive impact. So the clinical viewer, again, as we try to decouple a lot of the components within HealthShare and separate them by well-documented, contracted APIs, it means that the clinical viewer can be much more agnostic in terms of what system it is that's serving it its SDA. And so with the ODS as it is right now, it has that same search and fetch API that's defined on the access gateways as well. So the clinical viewer is still going to live on an access gateway. The access gateway is going to go to the ODS. It's going to hit the same search and fetch API that it would get directly on the access gateway. It's going to get an SDA container back that looks exactly like the same. And we did a lot of A/B testing, right? So we did a testing of the SDA bundle with ODS turned on and with it turned off to make sure that we're faithfully recreating the SDA in all cases. So it's going to get exactly the same data. It's just going to get it faster.
So are you going to build this with the ability to not have every single edge feed the ODS? Because we do appreciate the flexibility of having the distributed edge gateways. So sometimes we can bring one edge down or do certain data cleaning on one edge and not have that.
So that's a great question, and I don't know that we necessarily have a concrete answer for you on that. Typically, those kinds of questions are more around sort of pure query edge gateways, where it's querying data directly from the source system. In your case, I mean, certainly you can take an edge gateway down, and the ODS will continue to run. We do that as part of our standard resiliency testing whenever we're doing a release of HealthShare, is to make sure that all the other components function when an edge is down. In terms of having individual edges be configured to not feed the ODS, I don't think that we would probably make that an option. Just because, again, we want to sort of have a fair degree of consistency across customer deployments in terms of how these components are being used, so that when we develop functionality, we have a new functionality, we have a sort of reliable set of behavior on the underlying systems. If that is something that concerns you, catch me afterwards. Make sure I understand exactly what the problem is you're trying to address there. And I either may have a better answer for you, or maybe something that we have to add into the design to address. Have about 20 seconds left for a question. Tom, you got the last one.
Yes. All right, so following along with that, if I get a patient on edge A and edge B, A goes down, request comes in on B. You load the patient, but it doesn't get any data from A. When A comes back up, do you reload that, or?
That's a great question. I don't know. That's not something that we would typically design for. That's something that we would sort of address in our resiliency testing and make sure that we have a way of dealing with it sort of for our disaster plan. So I don't know the answer for you, but if you want, I can. I'll give you a offline email confirmation that I added that into the list of requirements. So, okay. All right. Well, so thank you for your time. Hopefully this was a better go around than last year.